afternoon, everyone. It's time for chemistry class, and today we'll be considering solubility. So, solubility. As the name, solubility is gotten from the word soluble. Soluble. When we say something is soluble, that means it has the tendency to dissolve. When we talk about that something is soluble, that means it has a tendency to dissolve, right? And if it has a tendency to dissolve, that means we're talking about solution. Solution. So we are talking about solution. So what then is solution? Solution is an homogeneous mixture that contains two or more substances. We are familiar with the word mixture, right? Homogeneous, as the word goes, one. That means it is uniform in its composition. That means homogeneous mixture that contains two or more substances. We know the characteristics of a mixture is that it is physically combined together. If it is physically combined together, that means it can be physically separated. So, we're talking about homogeneous mixture. And it's two or more substances that are physically combined together. In a solution is a mixture of basically two entities, the solute and the solvent. The solute, so solution is basically the solute and the solvent. The solute and the solvent. The solute is that part of substance that is present in small quantity. The substance present in small quantity. It can either be liquid, it can be gaseous, or it can be solid. So it can either be liquid, gaseous, solid. Whereas solvent is that substance that is present in large quantity. It's present in large quantity. Solute is the substance that dissolves in a solvent to form a solution. Solute is the substance that dissolves in the solvent to form solution. We established the fact that solute is present in small quantity, so it's that which is dissolved in the larger quantity, that's the solvent, to form a solution, and it is present in small quantity. It can either be liquid, gaseous, or solid. Consider liquid. It can be oil. Gaseous can be CO2, that's carbon dioxide, and this can be salt or sugar. And then let's talk about solvent. Solvent is the substance that dissolves the solute in order to form a solution. Solvent is the substance that dissolves the solute in order to form the solution. It is present in large quantity. It's present in large quantity, and it can take either of the states of matter. So in a solution, there can be more than one solute. There can be more than one solute, but solvent would only be one. The universal solvent that we all know is water. Benzene is also a solvent, right? So it can either be water, benzene, as the case may be. That means in a solution, we can have more than one solute, but we can only have one solvent. Let's consider soda drink. Soda drink. The solvent in soda drink will definitely be the water, right? And usually, the first ingredient in soda drinks is carbonated water. So let's talk about water. So the solutes, from the flavor to sugar to CO2 to preservative, and the list goes on and on. So there can be more than one solute in a solution, but there would only be one solvent. There would only be one solvent. Now, let's define the word solubility. What exactly is solubility? Solubility, by definition, Solubility of a solute in a solvent is the maximum amount of solute that can be dissolved at a particular temperature. So solubility of a solute in a solvent is the maximum amount of solute that can be dissolved in a solvent at a particular temperature. In the definition, you will notice particular temperature. That means solubility varies with temperature. So an increase or a decrease in temperature will have an effect on solubility. So solubility of a solute in a solvent is the maximum amount of solute that can be dissolved in a solvent at a particular temperature. So how do we measure solute? What's the unit of measuring solubility? Solubility is either measured in gram per dm cube or mole per dm cube. Then what is the formula? The formula for solubility in this regard of gram per dm cube is the mass of solute divided by the volume of the solvent. You would notice that it's in dm cube. That means your volume must be in dm cube. If you are given a question and your volume is in cm cube, you just need to divide by 1000 because 1000 cm cube is equals to 1 dm cube. And when we are dealing with mole, solubility is equals to the mole of solute divided by the volume of the solvent measured in dm cube. The mole of the solute divided by the volume of the solvent measured in dm cube. And if you are given in cm cube, you divide by 1000 in order to get equivalent of it in dm cube. Now we all know the formula of why using gram per dm cube and mole per dm cube. Let's take a calculation question. What is the solubility in mole per dm cube of 20.0 gram of KNO3 dissolved in 100 gram of water at room temperature? K, atomic number 39, oxygen 16, nitrogen 14. 1 second, please. Okay, so the first thing to do here is to write out our parameters. what is the solubility in mole per dm cube? So we are going to calculate in mole per dm cube of 20 gram of KNO3. So mass of solutes is equals to 20 gram. Dissolved in 100 gram of water at room temperature. From the question, we know that our solvent is water. So mass of solvent, because we are given in gram, is equals to 100 cm cube. But we are familiar with 1 gram of water being equals to 1 cm cube of water. 1 gram of water is equals to 1 cm cube of water. So I can as well write this 100 cm cube to be 100 centimeter cube. All right. Yes, this is 20.0. Thank you. All right, so from here, this is 1 cm cube, and we know that is 100 cm cube. And we have to calculate in mole per dm cube. And the formula is solubility equals to mole of solute divided by volume of solvent in dm cube. But we are given mass and not mole. But we can calculate our mole, since mole is equals to mass over molar mass. The mass given is 20. So 20 divided by, we're told the chemical formula, KNO3. KNO3. Atomic mass of potassium is 39. That of nitrogen is 14. And we have 3 atoms of oxygen, so plus 3 into brackets. Atomic number of oxygen is 16. So 39 plus 14. 3 times 16, 48. So let's punch this on our calculator. That's 39 plus 14 plus 48. That's 101. So we can as well write 101. So 20 divided by 101. 20 divided by 101 is 0.198 moles. Now we've gotten our number of moles, so we can use this formula. But our volume is in cm cube and not dm cube. And we're told to calculate in dm cube. I can also write this formula as solubility equals to mole of solute over volume of solvent in cm cube. I'm to divide this by 1,000, so it will be times 1,000 over 1. Any question here? Any question how we got this? All right. Okay. So this is mole of solute divided by volume of solvent in dm cube. And we know that 1 dm cube is equals to 1,000 cm cube. Right? And if we want to calculate for 100 cm cube, so 100 cm cube would be equals to x. So to calculate for the x, it would be x equals to 100 divided by 1,000. Right? And so here, since I'm to divide this by 1,000, since I'm to divide this, it's just like saying, okay, let me call this A over B divided by C. This can also be written as A divided by B over C. If I take this up, A will be equals to multiplication over, in order to change this division to multiplication. Are we clear? Any question? Finding it difficult. Okay, so let's just go with the normal flow. We know this is our mole, right? We're told to use dm cube and we're given in cm cube. So to convert it, I know that 1,000 cm cube is equals to 1 dm cube. So 100 cm cube will be equals to one particular value. Let's denote it as x. So let me calculate x. I'll cross multiply. X times this, that's 1,000 x equals to 100 times 1, 100 dm cube. To calculate for x, we divide both sides by x. 100, yes, 1,000, okay? We divide both sides by x, right? Yes, I've corrected that, thank you. So I'll divide both sides by this 1,000 in order to calculate x. So divide this by 1,000 and divide this by 1,000. This 1,000 will cancel this 1,000. 100 divided by 1,000 is 0.1 dm cube. Are we clear on that? All right, so let's use this value. So let's use this value. So solubility equals to mole, these are mole, 0.198 divided by our volume in dm cube, 0.1 dm cube. So let's point this on the calculator. 0.198 divided by 0.1. That's 0.0198 mole per dm cube. Any question? All right. One gram of water is also equals to 1 cm cube of water. 1 gram of water is also equals to 1 cm cube of water. And this is 100 grams. So 100 grams is definitely equals to 100 cm cube of water. Thank you. Any other question? Okay. In order to be fast, right, and not always converting our cm cube to dm cube first before we calculate, solubility can also be written as mole of solute divided by volume in cm cube. Okay, let us use it with that same question. Our number of mole that we got was 0.198, right? And our volume is 100 multiplied by 1,000. Let's see if we still get the same answer. Our initial answer was 0.0198. So let's see if we get it. So that is 0.198 divided by 100 multiplied by 1,000. Right? 101 over 20. So this is 20 divided by 101. That's 0.198, right? 0.198 divided by 100 multiplied by 1,000. That doesn't give us the answer. Did we do anything wrong there? Let's move on, Sha. I would explain later. Maybe when we are solving questions. Let's attempt. Let me see if there's another question here to attempt before we move on to type of solutes. Okay, so let's move on to factors that affect solubility. There are basically three factors that affect solubility. The first is the nature of the solute and the solvent. Nature of solute and solvent. I didn't get you. Are we putting syntax word? So what's your question? What are we? The unit is mole per dm cube. This is the unit. All right. Okay, so factors that affect solubility. First, nature of the solute and the solvent. We are all familiar with the word polar solute, polar solvent. So polar solutes will dissolve in polar solvent and non-polar solutes will dissolve in non-polar solvent. So polar solutes will dissolve in polar solvent and non-polar solutes will dissolve in non-polar solvent. Another factor that affects solubility is temperature. Temperature. You would recall in the definition of solubility itself, the last word there is at a particular temperature. That means temperature has effect on solubility. For liquid and solid, an increase in temperature brings about an increase in solubility. An increase in temperature brings about an increase in solubility. But for gaseous states, an increase in temperature brings about a decrease in solubility. Increase in temperature for solid and liquid results to an increase in solubility. So we can say that they are directly proportional. But for gaseous states, an increase in solubility, an increase in temperature rather brings about a decrease in solubility. Increase in temperature will bring about a decrease in solubility. Another factor that affects solubility is pressure. Pressure. And pressure is mainly for gaseous states. Pressure is mainly for gaseous states. An increase in pressure of the gas will bring about an increase in solubility because there will be an increase in the collision